Hi, Ms. Uzo. For my final project, I decided to make a flip book, How to Calc. Came up with that by myself. And to help a future student study the chapter of Chapter 5, and it's brought to you by Brody Carpenter, obviously. I'm going to have it copywritten pretty soon. Okay, so the first one, I just laid out some simple rules for differentiation and integration of ln of u, along with a few examples. I've also noted down here to know your log properties from pre-calc, because those will come up a lot. First, we have the derivative of ln of u is equal to u prime over u, and the integration side, the integral of u prime over u is equal to ln of u plus c. And I've laid out a couple examples there. I won't get into those because it'll be too long. And then for the next flap, we have the differentiation and integration of e to the u. And I've laid out down here, I kind of picked a weird place to put it because I did it before I had really planned out what the page was going to look like. I did the rules for the differentiation of e to the u, and the derivative of e to the x or e to the u is just e to the x times, and then for u it's times du dx times the derivative of u. And then on the integration side, I've laid out some rules up here. I have the integral of e to the x dx is equal to the e to the x plus c. And then I set out an example down here where I worked through that. Okay, the next flap that we are going to be doing is the derivative of an inverse. And so right at the top, I've just set out a basic function. I actually used the one from Khan Academy because I found that it helped me out a lot in my studying. I used f of x is just a normal function up here, and then g of x is equal to the inverse of f of x, which is denoted by a -1. Can't forget that I always used to mess it up with primes, and that's a really bad situation to get into. And then I took the derivative from both sides of this equation right here, which is basically the equation that lets you know if it's an inverse or not. You take the inverse and you plug in the normal function into the inverse, and you should get x, and then vice versa if you flip that around. So I derived both sides of that and got g prime of f of x times f prime of x equals 1, just using basic derivative rules that you should know. And then I basically just moved stuff around and found out what f prime of x was, which is 1 over g prime of x of f of x. And then I set up a little example over here in green so it's easier to read because I realized yellow was kind of tough. Move on to the next tab. I'll let you see that for a second. You can pause it. Moving on to the next one, I have the differentiation and integration of other bases, and you can see I've crossed that out because you're not going to be using that. It's everything but that. And basically I've set out a bunch of the rules on this side for the differentiation of basically something with a base that's not e, and basically the derivative of a to the u is equal to ln of a times a to the u times du dx, and that's like the basic one, and I've laid out some other basic ones right here. And then on the integration side, I laid out the basic formula, which is the integral of a to the x, which is equal to a to the x over ln of a, or 1 over ln of a times a to the x plus c. And then I've set out a little example down here where it shows you how to do it with when there's other numbers and like moving stuff around and stuff like that. Just a simple explanation. Okay. The next tab is the differentiation and integration of arc trig functions, and I made, actually up here, I made a chart that was in our notes, just to, something good to have, that has all of the arc trig functions on this side, their domain, their range, and the quadrant that they are in. And then I also wrote down here this quote, the arc sine x is the angle whose sine is x, because I feel like that helped me out a lot when trying to learn this stuff. And then down here, I just laid out all of the basic, I'm not going to read through all of them because I did all of the basic arc trig functions, and I wrote here at the bottom, memorize, because that's literally all you can do. I mean, this stuff, it's very confusing, but I feel like if you put it into like a Quizlet or something, it becomes very easy to do and very easy to memorize. Because I remember I originally knew nothing about it, and then I put it into a Quizlet, and it just became super easy for me to memorize. Okay, our next thing is going to be slope fields, and as you can see, I have a poorly drawn, kind of slope field, but I just showed you what it was. Here's our equation, and then I've laid out here a table where I found the slope at every point, and then basically what this tells you is it gives you a rough estimate right here, as I said, of the function, and then basically being guided by the slopes, you can get a rough guess of what that estimate looks based on where the endpoints are. Okay, and last but not least, for the finale, we have the separable differentiable functions. I'm trying to get a better angle, get this page, because I used the entire page. So I started off with y times dy dx in the top. Or I'm sorry, I started off with dy dx equals, sorry, it's kind of confusing because I showed my work. I started off with dy dx equals negative x over y times e to the x squared. And then as you can see, I've just basically moved all the y to one side and all the x to the other to get everything situated. And then I took the integral of both sides, moved out the 1/2 because of the e to the x power. And then, so basically what you'll end up with is y squared over 2 plus c1 equals 1/2 e to the negative x squared plus c2. And then you just move over the constants and just get another constant. So you end up getting with y squared over 2 equals 1/2 e to the x squared, e to the negative x squared plus c. And then basically with the coordinate pair given at the beginning, I just forgot to write it. I also used the Khan Academy video because honestly, Khan Academy basically is so useful. I don't know, he just brings out all these little tricks that help you memorize stuff. So this coordinate pair was given in the example problem. And then as you move all the way back up to the arrow, you take those coordinate pairs and plug them in. So you get 1/2 equals 1/2 plus c, and you get your c to be 0. And then you go back and plug that in to get this, and then you solve for y. And then you know that y is either going to be plus or minus the square root, but you know that it's going to be plus taking from the positive 1 over here because y is positive. And then you get down here and you solve for y, and you get y is equal to e to the negative x squared over 2. And that is my little flipbook thing on chapter 5, How to Calc by Brody Carpenter.